The post-quiz question I choose to talk about is 11P81. Design a decorative mobile to consist of a low-mass rod of length 0.49 meters suspended from a string so that the rod is horizontal, with two boards hanging from the end of the rod. At the left end of the rod hangs a ball with a mass 0.484 kilogram. At the right hand of the rod hangs a ball with mass 0.273 kilogram. You need to decide how far from the left end of the rod you should attach a string that will hold up the mobile. Set the mobile hangs motionlessly with the rod horizontal equilibrium. You also need to determine the tension in the string supporting the mobile. Okay. To solve this question, we first write down the system we want to consider is the rod plus the two-board system, and the surroundings consists of the earth, which acts gravity force, and the string, which acts supporting force. And because when we consider the whole system, we can find that the only three forces acting on system is the two gravity force and the supporting force. So we can draw the free body diagram here. Okay. And the first question asks about what is the tension in the string that supports the mobile. To solve this question, we first write down one of the fundamental principles. We use the momentum principle here. So we write down dp system dt equals to F net. And because in this situation, the rod and the board system didn't move, so the change of momentum equals to 0. So F net must equal to 0 according to the fundamental principle. And from the free body diagram here, we can see that F net equals to m minus meg minus m2g. And this equation equals to 0. So we can solve the supporting force as equals to 7.42 Newton. So the tension also equals to 7.42 Newton. The second question asks how far from the left end of the rod should you attach the supporting string. To solve this question, we first need to write down the angular momentum principle to help us solve the question. And we can see because the whole system here is in equilibrium, which means that it doesn't have any rotation or movement, so we can determine that at the angular momentum principle, the net change on angular momentum equals to 0. So the net torque act on the system also equals to 0. If we set d1 equals to x and d2 equals to the length of the rod minus x, we can write down the equation here that calculates the net torque of the whole system, which is mgd1 plus mgd2 equals to 0. One thing was noticed that according to the right-hand row, mgd1 is a positive number after page, while mgd2 is a negative number. So we put a negative sign in front of the mgd2, and we got the following equation that mgd1 must equal to mgd2 for the whole system to maintain equilibrium. So we solve for d1 equals to 0.18 meters. That's it. Thank you.